this vocabulary on top, you don't need to keep it here or write the vocabulary in here. I would much prefer you to take those vocabulary and put it into your notes notebook. So quadratic equation, it would be any equation. I don't know if there's going to be enough room here to write these all in. With the highest power being an x squared or being a squared. So in general, like y equals x squared, and then we can play around with those. We've been working with a lot of quadratic equations, things that have squareds in those. Parent graph, in this case, is going to be a y equals x squared. It's the graph we're going to compare every graph to. So comparing every graph to this. And we will have different parent graphs, and we could have a parent graph for linear, a parent graph for exponential, but we are looking at, like, this is the graph we're going to compare everything to. Our transformation is going to be how we change our graph. So changing graph, and it's like making it wider, narrower. It's going to be kind of that biggest piece on there. Translation is just physically moving a graph from one place to another, but the shape doesn't change. It's like if I took a pencil, it's still a pencil, and I'm just going to move it over a foot. I just translated that pencil. And then parabola and vertex, we should have some of those in the graph already. Parabola is the shape of our quadratic graph. It's that U or the upside down U. And I believe we did vertex where it changes from going up to going down or going down to going up. So looking at our first graph, our parent function is y equals x squared. So I can look at what that's going to look like by putting in all my x values. So negative 4 squared would give me a positive 16. And I can graph that on my graph. It's this one. I'll erase the other one. Negative 3 squared is going to be 9. Again, I can put them on my graph as I'm doing them. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. And then I get 1, 4, 9, 16. So again, we're seeing that symmetry. And then we're going to connect it. This is our parent graph. And what we're going to do is we're going to really be able to move these without a calculator, and it will become a lot faster than trying to put them in a calculator. So if we look at from our vertex, I like to do out and either an up or sometimes it's a down, kind of what we end up moving. So if I'm looking at my vertex, the first thing I'm going to do is going to be able to move out 1 over 1, which is this part here. So basically, if I move my vertex to a different location, I can still just go from the vertex out 1, up 1. From the vertex, if I go out 2, I go up 4, because 2 squared is 4. And if I go out 3, it's up 9. So it's kind of like the same chart. Ooh, something happened. It's kind of like the same chart. It's just slightly different. We usually won't get to the 416, but just in case it's on our graph, our graphs are normally smaller. We don't quite get that high. So if I'm looking here from your patterns that we did yesterday, this piece here is going to move our graph up 4 because it's a plus 4. It's outside of that function. So our new vertex is still at 0, but I'm up 4. So if I was going to graph that up in purple up above, I would go to my 0, 4, and now I can use my out and up 1, up 1, both directions because it's symmetrical, out 2, up 4, and then go back to the vertex every single time, out 3, up 9, 4, 5, 6, 7, 8, 9, and there isn't really room to do that 16 on there, but that kind of tells you this would be my new translated graph. Ignore that weird little mark. The next one, and I'm not going to graph all of them, I just wanted to graph that one. This minus 3 from our patterns piece last time should move our whole graph down 3. The shape of the graph doesn't change, I'm just moving it, and my new vertex is 0, negative 3. A plus 2, this one, It's going to be the opposite of what you think. It should move it to the left because -2 is what's going to make that equal to 0. So this is going to move it left 2. So it's -2, 0 is my new vertex. And this -1 inside the parenthesis moves it right 1. And my new vertex would be 1, 0. Again, in those parentheses, it has to do, think like that zero product property, what's going to make it equal to 0. And that's how that one's moving, just the opposite. And again, you saw that with the decimals and the patterns piece. So this one now I'm putting 2 pieces in here. And for your patterns piece, if this would have been a great way to be able to do, to kind of show a little bit more details on there, this +4 in here is going to move our vertex left 4. Again, it moves the opposite sometimes of where you're thinking. When it's outside, it moves it directly up in this case, so up 8. And then we would have our new vertex of -4, 8. So all these, we're going to kind of go through and move our vertex and graphing them. So inside, this is left 1 and down 3. So -1, 3. So I go -1, 3, put in a point. And then from that vertex, I'm using that out. And I'm moving up. So 1, 1, 2, 4, 3, 9. Again, I'm getting that from squaring them. Whatever I do to one side, I do to the other because it's symmetrical. And again, there's no room for 16, but I want my graph to still go to the edge. So I'm just going to kind of estimate where that would go somewhere in there. And that's my new graph. Our next one, inside where it's squared, this would be right 5. And that +0 does nothing. So when I'm putting this in, it's going to be 5, 0. And then from here, I'm still using that same out and up chart. 1, 1, 2, 4, 3, 9. And then drawing in my new graph. It's actually faster than typing it into a graphing calculator, looking at the table of values to make sure you're accurately graphing them. Our last one. So +2 would move it left 2. And then up 1. So left 2, up 1. That's where my vertex goes. I'm still going to use the same out and up chart. I have it on my screen, so I'm not going to rewrite it again. Up 1, out 1. Up 2, up 4. Out 3, up 9. And then I connect my dots to make my graph. Tomorrow we get into kind of changing that shape, but today our shape is staying all the same. Here, you're just going to write the parabola of those. So basically, I need to figure out where my vertex is. And once I know my vertex, they should not have changed. Some of the, sometimes the numbers will look a little bit different just because of the graphs that I took. But they shouldn't be making them wider or narrower or anything at this point. So if I'm looking here, this is moving left 3 and down 2. So it's going to be x + 3 squared minus 2. So I'm kind of using that ideas of what happened to make it go backwards. This one here, if I'm looking for my vertex, it moves down 4. And it moved right 2. So my new equation is going to be x minus 2 squared minus 4. There's no numbers on the graph, so we just assume that they're going up by 1. So my new vertex is going to be left 1 and up 2. So y equals x + 1 squared. Don't forget the squared. Plus 2. It's always frustrating when I see that it's like you have the concept, but you don't have that squared piece in there. In our last one, we move left 1, down 4. So y equals x + 1 squared minus 4. Again, if you have questions on this, showing up for Google Meet to get some help. Graphing them into the decimals calculator can also help if you're struggling or not quite understanding. It's a great way to check your answer to see, did it move the way that you thought it was supposed to? But you should be able to try to graph these without a calculator.